All right, so my name is Ben Lamothe. I'm the chief architect of Flurry. This is a little bit about Flurry. We're building a Clojure native graph database with a data-driven query language, time travel, semantic standards, and a bunch of bells and whistles. So I'm talking about error handling in core async. So we use core async is really versatile. We use it in a lot of different ways. But over my time of using core async, I've seen that you could really divide the way you use async channels into two buckets. So there's a class of channel that act like promises, and there's also a class of channel that act like sequences or seeks. So the channels that act like promises, they only ever contain a single value. You take off of that channel, you take that single value off of the channel, and then they immediately close. It usually is the result of the work that you have in a Go block. And it doesn't necessarily have to be a promise chan. It could be a normal many-to-many channel, but you execute a bunch of code in a Go block, you get an answer, and then you take something directly off of that channel. Then the other channels that act like seeks, they have multiple values on the channel, and you keep taking them off over and over and over again until they finally close. And they usually are the results of some asynchronous process that is constantly producing more values, but they're producing those values asynchronously. And so then you take those values, you put them onto the channel, and then you process them later on. And so when you have an exception in a core async construct, the typical thing that happens is the code runs, the exception gets thrown, and then you'll see a stack trace printed out to standard out, and then the channel that's dependent on that code closes without returning a value or do anything. And that's almost always not what you want in production, because you want to be able to handle that error. You want to be able to detect that. You want to be able to tell the difference between an error occurred or everything is fine, but just no data came out. And in your production code, it looks the same way because you're not listening to standard out. So you want to handle errors every time. And I think the most common thing that people do, the thing that I do, it works really well, is I don't know what people call it. I call it throwing take, but I mean, maybe people have other names. I believe it was popularized by David Nolan way back in the day, and I think everyone uses it because it's really powerful. But I think it works the best for the channels that work like promises, because you only have one value that comes off. And so that value could either be a normal working value or it can be an exception. So the throwing take is perfect for that. You take off of the channel. If it happens to be an exception, you just throw it anyway, and not have to worry about handling it at that necessary point. But then if it doesn't throw, then all right, I've got something that I can deal with and I can work with. Then you can think of error channels. So So you can think of an error channel is a single dedicated channel for an entire async process that reports all the errors that happen within the entire process. And then systems listen to both the primary output channel and the error channel at the same time with something like async alt. I think async alt works really well for this, but there are other things that you can do. And so one example is, this is basically lifted from the Flurry code base. This is how we execute queries. The first thing we do is we get a data source, a tracker for performance measurement, and then the parse query itself. The first thing we do is we build an error channel, And then we pass the error channel into every different process of the query pipeline. So first, we search for the data, we group it, we filter it, we perform the selections, we do whatever order by we need to do, we format the result set, we paginate it, and then we collect it into a one output. And then from that, you get a result channel. And we listen to both the error channel and the result channel, and whatever comes through, we know which one it came from, and we just return that. And the nice thing about this is now this is just a channel that returns a promise, or that behaves like a promise, even though it is a long process that does a lot of different things underneath the hood. But anything outside of this that calls query can just use a throwing take and say, is this an exception or is this a result set? And so it doesn't have to know anything about what's on the inside. So I think there's some benefits from the error channel approach. Is first, it mirrors the normal function invocation. So you've got an output channel that corresponds to the normal return value of a function, and then the error channel corresponds to the Java exception pipeline. And so just like you can throw, and that is handled at a different place in a different way from something that you return from a function normally, it's the same thing with, if it's a successful result, you put it on the output channel, and if it's an error result, you put it on the error channel. The other thing is that you can return an error anytime, and then it'll short circuit. You don't have to do any extra work. You get the error. It doesn't have to propagate up through the entire call stack. It goes directly to the thing that's listening to it. And so that all right, all the work that you have to do in between could be computationally intensive. Even handling the error, deciding what you should do with it, could be computationally intensive. Instead, you short circuit all of that and go straight up. You monitor for errors in one place, so you don't have to check for errors at each point in the call stack. You just monitor in one place. And I think it works well, as I said, for processes that use channels that act like sequences. There are some downsides. The downside is that you have to pass the error channel into every function. And so your function signature is it has one extra argument. And everywhere that could throw, it goes all the way down the call stack. A lot like in a Java API, every function that can throw, you have to add that throws argument. And so it's a little thing that you just have to keep doing. You have to create the error channel before you process the async result so you can pass it in. That's another little thing that you have to keep doing. And you have to remember to monitor the error channel, because if something is returned on the error channel and nothing gets to the result channel, then a lot of times you could have your program hang and you don't know why, because you forgot to monitor the error channel. And so I'm going to give an example. This is another thing lifted from the Flurry code base. So this is Flurry's query language. It's like I said, it's a data-driven query language. We've got the select clause here. I'm looking for the subject, the name, and the friend's name here. And then here's the where clause. It's nested map. It's a graph database, so we do hops, saying that getting different people that are known. And then I'm going to limit. The context is shorthand that I used in the query. I'd love to give a talk about Flurry so we can dive deep into what all this stuff means. But it's basically asking, give me the name of at most 10 people in the database who are over 21 and knows someone who's also over 21 and knows Kevin Bacon, along with the name of that person. And then after you parse the query, you get an execution plan, and then the execution plan is gonna look like these triples. So S, name, age, all of these. So this, I think, would be the previous slide is our own query language that we were actually implemented in a fever dream over a Christmas break. But I just thought it was awesome and that we should do it that way. But this looks a lot like Datomic, so I think a lot of people would be familiar with this. And so our query language decomposes into this under the hood. And each one of these vectors is an index range scan. So each one of these vectors is an index range scan. And the index range scan is the index, so Flurry stores its indexes in a B tree structure. And reading nodes from storage is an async operation. And any one of those storage reads could result in an exception. And channels returned from storage behave like promises, so they're perfect for throw and take. They will only either contain the node or contain an exception explaining that the storage read failed for whatever reason. And so the query engine could read multiple index nodes during a range scan. Each index node contains a sorted set of facts called flakes. Index nodes could contain flakes from multiple subjects, but the same subject's flakes could span multiple index nodes, so you can never know if you're looking for all the flakes for a particular subject, you can never know if it's contained in one node, two nodes, multiple nodes. It could be any number of those things. And then after it gets all the index nodes that it needs for a particular subject, then the query engine has to slice and dice the flakes from the index nodes in a lot of different ways in doing the query processing. And then the sequence of index nodes read from storage during a range. So yeah, the sequence behaves like a seek. The channel that contains that sequence behaves like a seek. So because of that, when you think about, like, the thing that I think makes core async such a perfect fit for Clojure and works so well with Clojure, because of this behavior. You could treat a channel like a seek. And we already know how to deal with seeks. We can map, we can reduce, we can transduce, we can partition, we could do all these different higher level functions onto sequences. And it's nice that core async and the core async API is extensive, and it has everything that you can do with a sequence. It has a corresponding analog that you can do with a core async channel and more. And so it's really well suited for error channels. The one issue with using something like a throwing take with something that uses those higher order transformation is that now I have to look and say, all right, like say if it's a function inside of a reduce, I have to say, okay, is this an error or is this a positive thing? Because I can't use throwing take inside of a reduce async function. And then I have to propagate that down, up and down the call stack, and then it makes it really, really difficult. And I think one of the things that a lot of people do to cope with that is just re-implement all of these higher order constructs using Go loops. And I think that's just a really imperative coding style that I think no one who uses Clojure wants to do. And they want to think at a high level and in a higher order. And so the way Flurry works is it reads all of the individual index nodes using throwing take and using the storage channels, treating them like promises. Then it puts all of those index nodes onto a single output channel, and that channel has a transducer attached to it. And that channel also can get piped into other processes recursively because, like I said, every triple in that execution plan that I showed is a separate async function, but it references the data that was defined in the previous ones. So it does a recursive loop over and over again in order to process a query. And then, and at all point, it's any error that can happen gets written to the same error channel. And so then at the end of the, and so if there's ever an error that process, all of those other recursive loops never happen again because, again, it's short-circuited. And so then, and at the end of the process, you're listening to the whole thing with alts. So yeah, I said some of the benefits before. We could design the system only to use channels that, so if we design the system only to use channels that behave like promises, we couldn't make use of higher level async constructs like pipeline async, reduce, take, that allow us to think functionally. We'd have to load all intermediate value, or we would have to load all intermediate values into memory to process them all at once. And one of the nice things about Flurry is that you can have a massive query that does lots of, that processes lots of intermediate results. But because we're using channels that behave like sequences and channels have built-in back pressure, we process the queries lazily. So if you do that big Kevin Bacon queries and there are tons and tons of people in there, you know that there's a limit there. Okay. There's a limit there, and so you cut off the limit, and you don't have to do any extra work that you don't have to, that is unnecessary after the limit is reached because of the way we process it. Yeah, that's my time, and I can answer any questions anyone has.
That's awesome. I think I look at this come back as a full talk because I feel like it's very relevant to my own interests as well. And any questions?
Yes.
Have you considered using Missionary? If you're familiar?
Yeah, I've looked at Missionary. I'm just more used to Core Async, and the reason why I prefer to use Core Async is because it seems more tightly integrated into the ecosystem. Because other libraries that you use have Core Async APIs as well. I think it's just another way to solve a similar problem with async code. But the thing that I appreciate about Core Async is about the similarities with sequences, and that's why I like to use it. David?
Yeah, maybe I should apologize about this throwing take. I mean, it was just because I didn't have any better ideas. Have you looked at, Rich Hickey came out with this Core Async flow?
Yeah,
I feel like he was kind of like, that was kind of his answer to being like, Core Async ends up being very imperative. Kind of like what you're saying. You do it and like you're excited at the beginning, but at the end you're like, I just wrote a bunch of like spaghetti.
I like Core Async flow. I like the idea behind it. I haven't had a chance to really play with it yet. But the thing that gives me pause about it is that whenever you have it's like line engine. Like wherever you have something that's really, really declarative, and it says, all right, I'm just gonna tell you what I want done, but I'm not gonna say how to do it. And then if one little thing goes wrong, then it's like, all right, what do I have at the wrong level of nesting? And like debugging is very difficult. But it seems like it has a lot of really good debugging tools, and there's a debugging UI. And so it might not be an issue. But the other thing about flow is that it seems like it's for long-running processes where these queries are totally ad hoc, and somebody issues a query and then the server comes in, creates this async pipeline, and then it goes away. And so I'm not sure if it's the right fit, if flow would be the right fit for something like this.
Is there anything you have to do that's long-running, like durable, as in it needs to start and then like pause and then resume after a restart sort of?
The server itself, and we use Integrant for that. Anything else? Thank you.
Awesome. Thanks so much, man. It's awesome.